And now we've come to our last topic, topic H, which will be interpreting numerical expressions. Now we're going to take everything that we've learned and be able to write out expressions and read expressions and be able to switch between English language versions and mathematical language versions. So, starting with this, kids will get words written out, and they'll have to explain that in math language, and they'll get math language, and they'll have to explain it in words like this. So A says twice the sum of 3/5 and 1 1/2, which would mean this. Twice the sum means the answer to an addition problem. So I'm going to add those two things and put them in parentheses because it's twice the sum of all of this. Then this, I would look at it and say, okay, it tells me that I need 3/4 plus this. I know that when I see the plus sign, I need to use the word sum. So I'm going to write that. The sum of, and the two things that are being added are these two numbers, 3/4 and 1 25/100. So I've done this, and then I'm dividing it by 1/3. So I'm going to write that, divided by 1/3. Now, by now, kids should know that dividing by 1/3 is the same thing as multiplying by 3. So if they wrote that, if they said multiplied by 3, that is an excellent understanding of what this means. We're trying to help kids see that these things are in two ways. Another point, I just want to say this is a thing that kids mix up on a lot, is if this was subtraction, which would get us in negative numbers there, but let's forget that. If it was subtraction, kids often struggle with this part because they see the word and in here. All that would change is this word. Instead of sum, we would write difference. The difference of this is still the difference of this and this. The difference is the subtraction part. The word and has nothing to do with the sign that's in between. We use the word difference or sum or product or quotient to tell what the sign is. The word and just means there's two numbers. So watch out for that if your kids are struggling with this part. After this part, we go on to problem solving, which will be next. Okay, I'm going to show you two kinds of problems that'll be in the very last section because they both build on things that we've done all throughout the module. So Carlo buys $14.40 worth of grapefruit. Each grapefruit costs 80 cents. How many grapefruit does Carlo buy? Well, let's solve that one first before we read on. He's got $14.40. And we are going to divide that by how much each one costs. And this, of course, is a simple fraction problem, just like we were doing before. Looks like this when we make it into a fraction. And like we did before, we're going to multiply to get the decimal out of the denominator. And in this case, I'm going to multiply by 10 because I don't want that 0 and I don't want to divide by 80. So I'm going to divide by 10. Multiply by 10, I'm sorry. I'm going to multiply by 10. And that's going to give me 144.0, but I'm going to forget that 0 too. Divided by 8. And when I divide that out, I think how many 8s are in 140? And that would be 10 that'd be 18. I'm decomposing to figure that out, and I would get 18 grapefruits. So simply by using this method that we talked about before, getting the decimal out of the denominator, I can easily do that division. Then I can answer B. At the same store, Kari spends 1/3 as much money on grapefruits as Carlo. How many grapefruits does she buy? Now, one way to solve that would be to look at the money and try to figure out what a third of that would be. But hopefully by now, kids have been doing enough of these kinds of problems to say, well, if she spent a third as much money, then she must get a third as much grapefruits. And so a third of 18, meaning we'd have to take 18 and split it up into 3 equal parts, meaning she would only pay $6. 18 divided by 3, a third of 18, and that would be $6 spent by Kari. And one final problem, and just a note, we're trying to help kids learn how to solve multi-step problems where they've got to use answers from one to solve another one. It's the kind of assessments they're going to be taking. So that's the purpose of these many questioned problems. Lucia has 3.5 hours left in her workday as a mechanic. She needs 1/2 hour to complete an oil change. How many oil changes can she complete during the rest of her day? Now this is a problem much like ones we've done earlier this module, where we've got the whole being 3.5 hours. And I need to divide it into halves. So I'm going to first show the 3.5 hours. 1, 2, 3. Maybe I'll cut that down a little bit because it should be a half. And a half. There's 1, 2, 3, and a half. And now I'm going to mark all the halves. Because I want to know how many half hours there are in 3.5 hours. So it looks like this. 3.5 divided by 1/2. How many halves are in 3.5? Well, there's a half. There's a half. There's one, there's one, there's one, there's one, there's one. And that would be a total of 7. 3.5 divided by 1/2. Again, by now kids should be knowing that the dividing by a half is the same as multiplying by 2. And they might just do 3.5 times 2, which equals 7. It is the same thing. Multiplying by the inverse is the same thing. So that would be A, as she can complete 7 oil changes. Now B, Lucia can complete 2 inspections in the same time as an oil change. How long does an inspection take? All right, so now we're talking about a half divided by 2. If she completes 2 inspections in the same time as an oil change, we're going to split that up and figure out how much it takes for her to do an inspection. So this time I'm going to be thinking about how that's how I can split 1/2 into 2 parts. So if this is 1 and this is a half, I'm going to shade that first. And then I'm going to, it should label that. That's 1/2. And now I'm going to divide that by 2. I'm going to cut it into 2 parts. This should look familiar from things we've done earlier. And then I'm going to ask myself, what is this part of the whole thing? 1, 2, 3, 4. That part there would be 1/4. And so it takes 1/4 of an hour to do an inspection. So now I know that it takes 1/4 of an hour, 1/4 of an hour to do an inspection. I can start to answer C. How many inspections can she complete in the rest of her day? And again, I'm going back up to the problem. I still have 3.5 hours left in my workday. Now I'm solving this problem. 3.5 divided by 1/4. How many 1/4ths are in 3.5? And I could go back and draw my tape diagram like I did before and have that half, 1, 2, and then figure out how many fourths are in each one. I could think, how many 1/4 are in 3? And think, gee, there's 4 1/4 in 1, so there must be 12 in 3. And then how many 1/4 are in 1/2? And there's 2 of those, and I could get 14 that way. Or I could think what I was saying before about when you divide by a number, it's like multiplying by its inverse, which would be 4. And just multiply 3.5 times 4, which is also 14. 3 different ways to get to this answer by now, so that kids have a variety of problem-solving strategies. And that's what we want for them, to have a bunch of different ways that they can model it to get to the same answer. Thanks for listening to us throughout this module.